A potential water-covered exoplanet, K2-18b, orbits a cool dwarf star called K2-18, lying 120 light-years away from Earth in the Leo constellation. This exoplanet, which falls between the size of Earth and Neptune, represents a unique class of celestial bodies not found in our solar system. Researchers investigating K2-18b's atmosphere have detected the presence of carbon dioxide and methane, aligning with predictions for a type of planet known as a Hycean world, characterized by an ocean planet with a hydrogen-rich atmosphere. Additionally, scientists have found a tantalizing hint of dimethyl sulfide, a compound typically associated with biological activity, particularly from marine phytoplankton on Earth. Traditionally, the search for extraterrestrial life has concentrated on smaller rocky planets, but larger Hycean worlds offer more favorable conditions for atmospheric observations. The habitable zone, where surface water can exist in liquid form, defines the distance from the host star. K2-18b, unlike Earth, is much larger and orbits its red dwarf star closely, completing an orbit roughly every 33 days. Nevertheless, the red dwarf's cooler and dimmer nature results in K2-18b receiving a decent amount of energy from its star, making it an interesting candidate for habitability. In terms of habitability, K2-18b is in what's called the habitable zone. This is the distance from a star where it's not too hot or too cold for liquid water to exist on a planet's surface. Liquid water is a key ingredient for life as we know it. Now, K2-18b isn't exactly like Earth. It's much larger and has a thicker atmosphere. Conditions in the oceans of Hycean worlds could resemble those in Earth's oceans, including temperature, pressure, liquid water, and energy from the star. However, K2-18b likely possesses a substantial mantle of high-pressure ice similar to Neptune, coupled with a thinner, hydrogen-rich atmosphere and a surface ocean. But what really has scientists excited is the possibility of life. If there are microscopic life forms in K2-18b's oceans, they could produce chemicals like dimethyl sulfide, which could be detected in the planet's atmosphere. Imagine tiny, invisible life forms swimming in its oceans. These little guys could release certain chemicals into the air, like dimethyl sulfide. Finding these chemicals would be like finding a secret code that says, life is here. Using the James Webb Space Telescope's JWST instruments, astronomers have detected carbon molecules, carbon dioxide, and methane in K2-18b's atmosphere. But here's the catch. Even though these discoveries are super exciting, they don't prove for sure that the planet can support life. Future JWST observations, especially with the mid-infrared instrument, MIRI, will provide a more detailed examination of dimethyl sulfide and other potential biosignatures, bringing us closer to determining if K2-18b could support life. This research showcases the capability of JWST in detecting biosignatures on exoplanets, a vital step towards identifying extraterrestrial life. I hope you enjoyed watching this video, and if you are interested in more content like this, please consider subscribing to explore. These videos might catch your interest. I highly suggest that you watch them.